Hello there, everybody. This is a video about the conditions for triangle similarity. We talked about similarity, similar figures anyway, being the same shape, but not necessarily the same size. Later we'll talk about congruent shapes being the same shape and the same size. But for similarity, similar figures are just the same shape, not necessarily the same size. So if you think about enlarging a picture of yourself, the you in the original picture is similar to you in the enlarged picture. Everything's the same shape but different sizes. And the same applies for when we're talking about triangles and other shapes as well. Similar shapes, they are the same shape but not necessarily the same size. And we've also talked about similar figures always having all three side ratios the same. So if we said these two were similar, this side divided by this side, and that side divided by that side, and that side divided by that side would all give us the same thing. And then all the angles in the shape have to be the same as well. So there's kind of six things, three side ratios and three pairs of angles that we've got to check in order to show that triangles are similar. And that is a lot of work. So this lesson is really about, are there shortcuts for showing that triangles are similar? And thankfully there are, and there are three, and you'll see those here in a second. So for triangles, here we've got two triangles. We see that both triangles have a 78-degree angle. Both of them have a 60-degree angle. So they have two angles that are the same. Now we could find this one and this one, because we know that the angles in a triangle add up to 180. We could take away 60 and 78 from 180, and we'd get this angle. We could take away 60 and 78 from 180 to get this angle as well. And these two are going to be the same. We don't really have to find it. And this is one condition for triangle similarity. If we have two pairs of angles that are the same, then the triangles have to be similar. We don't need to worry about the sides. We don't even need to worry about this third angle. These third pair of angles have to be the same if the first two aren't. So what are we saying here? We're saying if two pairs of, I should put corresponding, angles are equal, then the triangles are similar. All right, so this is one condition for triangle similarity. We have two pairs of angles that are the same in these two triangles. That means those triangles have to be similar. Now, that was a lot of writing. If I asked you to whether these triangles were similar and to explain your reasoning, you'd have a lot of writing to do. So from now on, we're going to, instead of writing that whole big long sentence out, we're going to call that angle similarity. So angle, and then the similarity symbol is just another way of writing this big long sentence. We understand that these two things mean the same thing. So when you see angle similarity, you know that means if two angles or two pairs of corresponding angles are equal, then the triangles are similar. So this is one of the three conditions that we're talking about today. Now this pair of triangles, we don't know anything about the sides, or the angles, excuse me. We don't know anything about the angles. All we have information about are the sides. And it turns out if we have three pairs of side ratios that are the same, then those two triangles have to be the same. We don't need to know anything about the angles. If we do, we can use it. But if we don't, all is not lost as long as we have some information about the sides. So let's check these side ratios and see what we mean here. Let's see, 10 is the smallest side in this triangle, and 4 is the smallest side in this triangle. So 10 and 4 are going to go together. Now 10 divided by 4 is 2.5. Let's see, the longest side here is 25, the longest one here is 10. 25 divided by 10 is 2.5. Oh, same ratio. That's a good thing. Let's see, the middle one would be 20. Middle one here is 8. So 20 over 8 is also 2.5. So all three of those side ratios are the same. That means these triangles have to be similar. And rather than writing out that big long sentence, kind of like we did up here, the way we abbreviate that is side, 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 similarity. So these S's just mean that we have side ratios that are the same. And that is another one of those conditions for triangle similarity. So we don't have to show that all the angles and all the sides all the angles are the same and all the sides give the same ratio. We don't have to show all that stuff. As long as all the sides give the same ratio, we don't need to worry about the angles. We automatically know that the triangles are similar. Now there's one more condition, and it's kind of a combination of the two. Here we got one pair of angles that are the same. We got two pairs of sides. Now, we know these angles are the same. Angle O and angle H are the same. That's what these arcs mean. Let's see what happens with these side ratios here. Let's do 6 over 8. Let's see, 6 over 8, that's 3/4. 6 over 8. 3 over 4 is the other ratio. That's already reduced. So let's turn these into decimals instead. Maybe that'll be a little more. So that's 0.75. 3/4 is 0.75. Those ratios are the same. And we've got an angle in between the two sides, that's important, that are the same also. This is enough for us to say that these triangles are similar. And it's not side, side, side. It's not angle, angle. It's side, angle, side. Similarity. In each triangle, we have an angle in between the two sides. Now, those angles in the two triangles have to be the same, and the two side ratios have to be the same also. So there are our three conditions for triangle similarity. Angle, angle, side, side, side similarity, and side, angle, side. So let's see a couple of examples of this here. So here I've rewritten our three possibilities over here. Here we got a couple of triangles. We want to know if they're similar or not. Okay. Now all we have information about here are the angles. So that means that if these are going to be similar, we've got to use angle, angle. Okay. So we've got to have two pairs of angles that are the same. So both triangles have an 89-degree angle. This one has a 60 and this one has a 32. So it doesn't look like we're going to have two pairs of angles. But we do have the ability to find these other angles here. We can, because we know the angles in a triangle have to add up to 180. Same with this one. So we could go 180 minus 89 minus 60, and we would get 31 degrees. Okay. Now, 31 and 32 clearly are not the same. So I don't think these are going to be similar because the angles are different. Okay. And to double check, we can do 180 minus 89 minus 32. We would get 59 degrees. And we can see that, again, these two aren't the same either. One pair of angles is the same is not enough for us to say that they're similar. We need two, and here we clearly don't have it. So these are not similar. Let's take a look at this other one. Okay. Well, we don't know much about the angles here. So angle, angle is probably not going to be the one we do. We've got two pairs of sides. Two pairs of sides kind of makes me think about this one. Kind of makes me think about side, angle, side. But we also need a pair of angles that are the same here too. Well, this angle is between these two sides, and this angle is between those two sides. Those are the two that would have to be the same. Is there some way that we could figure out that they are the same? Well, the answer to that is yes. They are actually equal because they're vertical angles. We learned about those vertical angles in Chapter 2. Vertical angles are always the same. So as long as these side ratios are the same, I think we're going to have side angle side similarity here. So let's see if they're the same. Let's see, 10 is the smaller of these, and 15 is the smaller of these. So let's make a ratio out of those, 10 over 15. And that gives you 0.6 repeating. 12 is the bigger one, and 18 is the bigger one here. So 12 divided by 18, you can plug that in your calculator if you want. It is also 0.6 repeating, and we get the same ratio. We have two pairs of angles in between those, or one pair of angles, sorry, in between those sides that are the same. So yes, these are similar. Yes, they are similar. And the reasoning is side angle side similarity. And there we go. Good luck on your assignment. Let me know if you need some help. Bye.